Welcome back. Now we'll discuss performance of oil-fired furnace. First, we'll discuss classification of different furnaces. Based on various criteria, we have different types of furnaces. So, based on the methods of generating heat, we have two type of furnaces: combustion type and electric type of furnace. Further, combustion type of furnaces are classified on the basis of fuel use, and it can be broadly classified as oil fired, coal fired, or gas fired. Further, furnaces are classified on the basis of mode of charging of material. The types are intermediate or batch type furnace or periodical furnace and the continuous furnace. Furnaces also classified on the basis of mode of waste heat recovery as a recuperative and regenerative furnaces. Another type of furnaces are based on mode of heat transfer, mode of charging, mode of heat recovery. So this is about the classification of furnaces. Now what are the desirable characteristics of the furnace to get the maximum efficiency? Means what is the characteristics of furnaces or requirement of minimum fuel and high quality heating and with the minimum pollution. So determination of the quantity of heat to be imparted to the material or charge, that fuel should be required less for typical heating. Then liberation of sufficient heat within the furnace to heat the stock or overcome all heat losses. Then transfer of available part of that heat from the furnace gases to surface of heating stock. Equalization of the temperature within the stock and within the furnace. Then reduction of heat losses from the furnace to minimum possible extent. So these are some desirable characteristic of the furnace for efficient operation. Furnace energy requirement. Since the products of flue gases directly contact the stock, type of fuel chosen is of importance. Sulfur in the fuel and particulate matter generated limit the use of solid fuel like coal, wood, and that's why the majority of the furnaces use liquid fuel, gaseous fuel, or electricity as an energy input. Melting furnaces for steel, cast iron use electricity in induction or arc furnaces, and non-ferrous melting utilizes oil as a fuel. Oil-fired furnace. Furnace oil is the major fuel used in oil-fired furnaces, especially for heating and heat treatment of materials. LDO is used in furnaces where presence of sulfur is undesirable. The key to the efficient furnace operation lies in complete combustion of fuel with minimum excess air. Furnace efficiency is too low and it is up to 7% because of its high operating temperature. At the same time, boiler efficiency is 90%. High temperature operating temperature result into low efficiency, and the exhaust gases from the furnace are also leaving the temperature equal to operating temperature and carries huge amount of heat result into significant reduction in efficiency. Improvements by methods such as preheating of stock, preheating of combustion air, and other waste heat recovery systems. Typical furnace systems are forging furnaces, then re-rolling mill furnace, in which we have two types, batch type and continuous pusher type, and third one is continuous steel reheating furnaces. Now heat transfer in furnaces. Furnace is operating at very high temperature, so radiation is one of the main component mode of heat transfer in furnace, and the radiation takes place from flame, hot combustion products, and the furnace walls and roof. And another mode of heat transfer is due to convection, due to movement of hot gases over the stock and in the furnace. So heat transfer takes place in a furnace by radiation mode and convection mode. Now we'll discuss performance evolution of typical furnace. The heat supplied to the furnace in the form of fuel, which is 100%, is distributed in a different way. Some is used to heat the stock, some is stored in the wall, some is carried by exhaust gases, some is carried by the moisture in the fuel and air, some is carried by the cooling losses. So the heat supplied, which is 100%, is distributed in this way. The heat storage in the furnace structure, stored in wall, material handling losses, and this typical loss in high temperature furnace is 2.64%. Losses from the furnace outside the wall and structure. Then heat transport out of the furnace by load conveyors and fixture trays. Then heat carried by moisture, which is high, 10.5%. Then radiation losses from opening, hot exposed part, etc., 5.6%. Heat carried by exhaust gases is 57%. See, the component of heat carried by exhaust gases is 57% because of high temperature operation of furnace. Then heat carried by cooling media. Then heat carried by the cold air infiltration into the furnace. So these are the different processes taking place in the furnace when we are heating stock material by burning fuel. And this percentage is for typical oil fire reheating furnace operating at 1340 degrees Celsius. The performance of a furnace is evaluated by two ways, direct method and indirect method. In direct method, we have thermal efficiency is equal to heat stored in the stock material upon heat supplied by the fuel. Heat, which is typically 25% for the furnace operating at 1340 degrees Celsius. So the losses is 75%. And the heat stored in the material or stock is MCP T1 minus T2, where Q is the heat stored in the material, M is the mass of the material, Cp is the specific heat of material, T1, T2 are final and initial temperature in degrees Celsius. Another method of evaluating performance is indirect method, in which the efficiency is obtained by subtracting various losses from the input. Input is heat of fuel supplied, which is 100%, minus various losses, gives the efficiency. So 100 minus 75% are the losses by different way. So the efficiency is 25%. So first method is simple to evaluate the efficiency, but the second one is complicated, but to provide the scope to uh, identify the gap or scope for energy saving, or which loss we can reduce. That is given by indirect method. Now certain measures are taken to improve the performance of furnace, and the measures which we can be taken for improve performance. First is complete combustion with minimum excess air. So we have already discussed exhaust gases carries lot of amount of heat, which is 57% for the reheating furnace operating at 1340 degrees Celsius. And as excess air increases, losses further increases. So there should be complete combustion with minimum excess air. If the combustion is not complete, then again there is heat loss. Then correct heat distribution. So flame should be in a uniform way, and the burners are positioned in such a way that the flame will not strike the wall of the furnace or strike the stock material, and the heat should be uniformly distributed. Then operating at desired temperature is also one of the main parameter. Then reducing heat losses from the furnace openings. So we should minimize openings from the furnace to avoid radiation losses. Then maintaining correct amount of furnace draught. By increasing draught, the rate of flue gases increases, which carries more heat to the atmosphere and reduce the efficiency. Then optimum capacity utilization is also one of the effective efficient operation measures. Then waste heat recovery from the flue gases by various ways for reheating of the stock material, reheating of air required for combustion, then minimum refractory losses, and use of ceramic coatings to the wall of furnaces. These are the 9 measures we can take in the furnace to improve the efficiency. Thank you. If you have any query, mail me on hdbarate@kkwac.edu.in.